All right, guys, welcome to this page of the notes. We're going to continue with this idea of solving systems of three equations. And what we've got here is a nice long one. We take a look at it, and I don't have any equations that only have two or fewer variables, which means substitution is not going to be a good option. Elimination will be much faster, and so that's the way we're going to do this one. So how do we get started with elimination? Well, if you remember systems of two equations, in order to figure out what to eliminate, what we did was we took a look at the coefficients. What you're looking for is a variable that has the same coefficients with opposite signs. So we take a look at the problems I've been given, and I know that I have an x with a plus 1, an x with a plus 1, and an x with a plus 2. Well, not all of those coefficients are the same, and they're all the exact same sign. Everybody's positive. Probably not a good option, but we'll keep looking. We'll see. The z. I got a plus 1, a plus 2, and a plus 2. Okay, awesome. Those two are the same, but that one's different. So I do have two different coefficients. And again, they're all the same sign. So that's probably not going to be the best option, especially when I take a look at the y's. The y, everybody has a coefficient of 1. Fantastic. And then I have a plus y, a minus y, and a plus y, which means the signs are different. We found ourselves a winner. We're going to go ahead and eliminate the y first. Let's make a little note. Eliminate y. All right, here's how we're going to do it. Number your equations. There's equation number 1, number 2, and number 3. Here we go. Your first step in order to eliminate y is we are going to add equations 1 and 2. When I do that, the y's will drop out. So we are going to add. Equations 1 and 2. All right, here we go. I'm going to have x plus y plus z is equal to 2. That's equation number 1. I'm going to have x minus y plus 2z is equal to a negative 1. That's equation number 2. I add them up. The y's drop out. Fantastic. Keep going. X plus x is 2x. Z plus 2z would be 3z. And I wind up with, what is that, a positive 1. All right, I just found a new equation. Make sure that you know, nope, I don't want to number that one because that one's got a weird gap in it. Hang on, let me rewrite it first. There's equation number 4. Got myself a brand spanking new equation. This equation has just an x and a z in it. Awesome. Next step. I can now add equations 2 and equation number 3 because the y would drop out of those as well. All right, here we go. Let's add equation 2 and 3. All right, well, that's going to be x minus y plus 2z is equal to a negative 1. That's equation number 2. And 2x plus y plus 2z is equal to 2. That's equation number 3. We add them together just like we wanted. The y's are eliminated, and here's what I wind up with. 3x, 4z, and that's going to also be a positive 1. Let me rewrite it. 3x plus 4z is equal to 1. And that is going to be equation number 5. We just found ourselves another new equation. Now at this point, hopefully what you can see is you have taken this system of 3 equations and you have boiled it down to 2. This one and this one. Well, we spent an entire section, chapter 3, section 1, solving systems of 2 equations. I have 2 equations. I have 2 unknowns, xz xz. We've done this, right? We're now going to proceed with this problem just like you would if you had a system of two equations. I'm going to use elimination to eliminate one of the variables and solve for the one that's left. So here we go. We need to take a look at this. I'm going to need to do elimination, and unfortunately I don't have any variables that have the same coefficient with opposite signs. In fact, I've got nothing. I don't even have anybody that has opposite signs. So we're going to have to do quite a bit of work here, actually. Remember, the tip here is LCMs, right? The LCM of the x's would be 2 times 3, which is 6. The LCM of the z's would be 3 times 4, which is 12. You want to go with the one that has the lower LCM. So it looks like we're going to say goodbye to x. We're going to eliminate the x's. So here we go. We're going to go ahead and make ourselves a little note, right, so we don't get lost. And here's what my note is going to say. I'm going to add equation 4 and 5. So we're going to add equations 4 and 5, and we're going to eliminate x. All right, well, here we go. I have 2x plus 3z is equal to 1, and I have 3x plus 4z is equal to 1. Now, I'm going to need to multiply these guys by something. And let's go ahead and see if we can think ahead, right? Remember, I know already my LCM is 6, so I'm going to need to multiply the first equation by 3. And I'm going to need to multiply the second equation by 2. But when I do my addition, I would like to get positive numbers if I can. Well, if I multiply this equation by 3, that's going to give me a 9 here. If I multiply this equation by 2, that's going to give me an 8. So which one do I want to be negative? I want the smaller number to be negative. So that means this is going to be the minus 2. That's going to be the positive 3, and hopefully when I do my addition, I'm going to wind up with positive numbers. Woohoo! Here we go. I now have 6x plus 9z is equal to 3. I have minus 6x minus 8z is equal to a negative 2. We add those guys together. The x's drop out because I put a little forethought into it, thinking ahead. 9z minus 8z leaves me with z, just 1z. And 3 plus a negative 2 is 1. And what I wind up with is the value of z is 1. So, awesome, we got our first one. But now here's what we need to do. We need to go back and find the rest of them. I still need to know what x is, and I still need to know what y is. Well, I got a couple of good options here. Now that I know z, I could do either equation number 4 or equation number 5, right? If I plug z in here or z in here, I could solve either one of those for x. Pick the one that looks easiest. I'm going to go with equation number 4. So here we go. We're going to do 2x plus 3z is equal to 1. I plug what I know z to be in, so I have 2x plus 3 times 1 is equal to 1, which means that 2x is equal to 3 times 1, of course, is 3. I'd have to subtract it to the other side. 1 minus 3, which means 2x is equal to a negative 2. X is going to be a negative 1. Okay, here we go. I now know what z is equal to. I now know what x is equal to. How do you find y? Well, since I know what z is equal to and I know what x is equal to, plug those values into any one of these 3 equations. Of course, pick the one that's the easiest to work with, but plug it into any one of those equations and solve for the only variable you don't know, in this case, y. So here we go. I like that first one. That's definitely going to be the easiest one to solve force, so that means I'm going to be solving x plus y plus z is equal to 2. Let me make sure that that's right. Is that what I had? Yeah. X plus y plus z is equal to 2. Plug in what we know. Well, x is a negative 1. Z was a 1. Negative 1 and 1, actually those cancel each other out, and y is equal to 2. And so therefore, my answer, my ordered triple, is going to be x, negative 1, y, which is a 2, and z, which is a positive 1. That's my solution. Fantastic. Again, guys, I know it's long, lots of steps, but again, number your equations, show your work, make yourselves little notes, and it's not that terribly difficult to kind of work your way through this problem. But of course, practice helps, so let's do another one. Head on over to the next page of the notes, and I'll meet you there.